We're live. Hi, everybody. Thanks for joining. This is Dan Reecer from the Web3 Foundation, and I'm joined here by my teammate, Bill Laboon. We are here to talk to you guys about a presentation on Polkadot for beginners. And really the goal with this is to give a very simplified, kind of jargon-free explanation of what Polkadot is, along with the background of the internet and that leading into the formation of the blockchain industry. Let's start off with Bill. Maybe you can give a quick introduction of yourself, and then I can do the same, and we can get started.
Sure. So hi, everyone. My name is Bill Laboon. I am the technical education lead here at Web3 Foundation in Zug, Switzerland. I've put up a slide with some contact information in case you're interested in reaching out to me. I come here after 5 years as a lecturer in the computer science department at the University of Pittsburgh, and am loving the sunshine here today.
And I'm Dan Reecer. Like I mentioned, I work on community and growth here at the Web3 Foundation, primarily focused on our two primary brands, Polkadot and Kusama. I recently I started in blockchain a couple years ago, actually going on 3 years now. And then before that, spent a lot of time in the pharmaceutical industry at the beginning of my career. So Bill, I guess go ahead and get started with the presentation, and I'll minimize myself.
Okay. So just before we start, I want to reiterate what Dan said, is this presentation is really meant for beginners. So if you do hear me use some jargon, I will try not to, but in case I accidentally slip up, please feel free to hit ask a question, and Dan will be monitoring it to see if there's anything that we can help with here. So this, again, is meant for people that may have heard of blockchain or they've heard of Polkadot but aren't really sure what it is, what it's used for. You don't need to have any sort of background in blockchain in order to get something out of this. We're really going to start at the very beginning. So please feel free to ask questions. There are no dumb questions. There are no bad questions. If you don't understand something, it's my fault. So please feel free to ask. So just to give a brief overview of everything that we're going to cover, I want to talk briefly about how the internet came about and how it has evolved, and the history as well of blockchain and crypto, as well as a lot of the similarities between the two. We'll also explain what blockchain is, the issues with legacy blockchains, and how Polkadot solves them, and what we expect to see, although it's very hard to predict the future, happening with Polkadot in the long-term time frame. So let's go all the way back to the late 60s. When computers were first created, when people first started using them, they really were islands unto themselves. You had an individual computer, and if you wanted to bring information from another computer, you put it on a diskette or a reel-to-reel tape or a bunch of punch cards and brought it over to the other computer. There were a few experiments with networked computing systems starting in the mid-60s, and the most famous one was ARPANET, and arguably the most popular at this time, which connected many of these different computing sites. You'll notice a lot of these sites here are universities, CMU, Rutgers, Illinois, some such as NSA are not universities. One of the interesting things I found looking on this map that NORSAR, one of the first non-US parts of ARPANET, this first precursor to the internet, was a Norwegian seismological research center. I'm really not sure the story behind why that was one of the first connections to the internet, but there you go. So something I want you to sort of think about in terms of evolution here is that we had these individual island computers, and they slowly were getting more connected throughout the 60s and 70s. But it wasn't like nowadays where you have a network connection in your pocket. If you were in Harrisburg or Philadelphia, for instance, well, you would have to, if you wanted to connect to the ARPANET, you would drive down to Aberdeen in Maryland or CMU in Pittsburgh, et cetera, and that would be the only way to connect. Another interesting thing I want to bring up here, when this network first started, people really saw it as a way to increase the computational power of these computers. They said, well, if this computer is really good at doing this kind of math, and this computer is very good at doing this other kind of math, maybe we can combine them to solve more complicated math problems. So I think you'll see we didn't really understand what this network was going to be used for when we first created it. And in fact, very quickly, it became apparent that communication was a major part of what people wanted to use this network for. Before there was email, people would actually basically send files or update files in other people's home directories to send messages to others. Soon after that, in the early 70s, this was formalized into like a real email system. And very quickly, people started using it. In fact, Queen Elizabeth II sent her first email in 1976. For a long time, email was sort of the most advanced, most complicated technology that we were using on top of this network. And then in '78, there was a real sea change where Robert Kahn and Vinton Cerf created a series of protocols, basically just rules, that allowed networks to connect to each other and different networks to connect to each other. Think of it as an Esperanto, a standardized language that all of these networks could use. And in 1983, ARPANET, which was the largest network at the time, adopted this mechanism of communicating. Again, think of it as it developed Esperanto or English. Instead of individual languages, there was some generic language that we could all use. So now that there was this common protocol, we had other networks joining the ARPANET. And so instead of just the ARPANET, it was NSFNet and DoDNet and all of these different networks, FidoNet, that could all connect to each other and talk to each other using the same language. Eventually, ARPANET was decommissioned, turned off, and that gave birth to the internet. They had already made a system that allowed all of these different networks to interact with each other. So we've gone from individual computers to computers interacting with each other at networks to now all of these networks talking to each other. And once we had this, we suddenly see an explosion in the 90s in terms of things that could be done. On top of TCP/IP, the generic language protocol that these computers were using, other protocols were developed, such as HTTP, which you may have seen if you've ever entered at the top of a web page, http://whatever. This is a protocol built on top of TCP/IP, which enabled things like web pages. After that, we started getting commercialization of the network. So we had Netscape, and we had the .com boom in the 90s. Amazon, Google, and in fact, many of the largest companies now are, do things that would have been unthinkable back in the 60s when people were first thinking of how to connect these different computers to solve math problems more effectively. When you think about, you pick up your phone and you share a cat picture, can you really imagine someone in the 60s doing that? Or them thinking like, oh, but the fact that these networks can intercommunicate means that someday a company with the strange name of Google will be able to get a lot of data, and that's going to help machine translation, so I can automatically translate Slovakian to Russian or whatever. So one of the things I want to show you is that as these connections grow, as the network grows, more people can use them, and as anyone can use these networks, different things happen that are very hard to predict from the beginning. But this intercommunication and this networking has been very, very effective in bringing new ideas into place and allowing people to implement them. So if we look really at like the 70s, we had a lot of technology being developed that now helps lay the groundwork for how computers communicate with each other. So TCP/IP is just how do networks interact. SMTP is simple mail transfer protocol. How do emails get sent to each other? HTTP is how does a web page get sent to your computer? Tools are built that use those fundamental protocols that everybody shares. So the apps on your phone, your email client, your web browser. And on top of that, what we see are the user applications. The social media, the search engines, the news sites, whatever you use your computer for, your phone for, whatever you access the internet for, really depends upon these lower levels, these foundational levels that were developed over time. So that is this basic idea I want to get across from you, is that this was a slow process of developing fundamental protocols and allowing better communication, and how that led to the modern internet. So I want you to keep that in mind as we start talking about blockchain and its history and how it developed. So blockchain, I know it's a fancy buzzword, but really all of it is chunks of data. So each chunk of data, and this is usually like data that is associated with a particular time period, like what's happened over the last 10 minutes, connected in a chain and distributed among many different computers. There's no centralized spot where the blockchain lives. There's many computers that are all adding on to this chain, and it cannot be altered once all of these computers agree on what the next block is. So I think a good example, and I'm not going to take credit for this, is a poker game. So if at the end of every hand, everyone records the results of who won the poker game, and what the hands all were, and how much money was put in the pot, think of each one of these as a block. And after the game is complete, you could look through this whole list. Assume everybody is checking. We're writing down in full view of everyone else what the hands were. Everyone can see, everyone can make sure what you're writing down. At the end of the game, you also can confirm with each other how the game took place, who has how much money. So if somebody tries to take out more than they're owed, everyone else can look and say, no, you started with whatever, $100, and you won $200 here, but you lost $50 here, and you gained $90 here. At the end, you should have, let's say, $70. You can't take out $170. But this can be done entirely automatically. If you are a chess player, you've probably also seen this. You write down your moves in chess so that anyone can replay that game just looking at the sheet, even if they didn't see the game itself. So if we look at an actual block, so that's the basic idea, is after every hand, think of every hand as a block, we could just have transactions in there. So this is how a Bitcoin block works, for instance. So at the beginning, and each of these blocks represents one day. Dan has 5 million, but Dan pays Kevin 5 million. Kevin pays Bill 2 million, and Bill pays Dan 1 million. That's a block. All of the computers can double check each other to make sure that they all agree. As the days move on, we see all the transactions, and anybody can replay this blockchain and see at the end that Dan has 500,000, Kevin has $0, and Bill has 4.5 million, which would be very nice for me. But anybody can do this. Anyone can look. This is all public, and nobody can go back and try to change things. If they do, the reason nobody can change these things is because this data is not stored in a single place. If Facebook.com went offline, there would be no way for anyone to access their data on Facebook. But with blockchain, it's a decentralized network. all of the computers that are on the Bitcoin blockchain actually have their own copy, their own verifiable copy of the data. So it's very, very redundant. Even if half of those computers get knocked offline, or 90% or 99%, as long as one node, as we say, one computer is still on with the Bitcoin blockchain, it can be replicated again. If someone does try to change something, it will be visible to everyone. If I try to say, or excuse me, that Dan did not pay me $500,000, so I edit the data on my own computer to say that Dan actually paid me $1 million, everybody else can verify that that's not true, that that was just me trying to cheat Dan out of an extra $500,000, which I already have $4.5 million here. Why would I do that? But everybody can look. We can avoid this sort of situation. Once that block is in the blockchain, it is, as we say, immutable. It can't be changed. Everybody can verify very easily if somebody tries to change what happened in the past. So we have all of these different computers all over the world, all checking on each other to make sure that none of them are telling a lie, right? So if I modify my computer here in Canada, then the other computers, in Brazil and Russia and Australia and Namibia, all of them can say, no, you can't trust this node. Don't listen to what it's saying. We all know what the real truth is. So that's from a very high level what it does. But why would a user care about blockchain? Well, one of the really cool things about this is that all of the users on the network can agree on what's in the blocks without trusting each other or even really knowing each other. So you can have this trustlessness that I may not trust that some individual person is going to cheat me at the store. Like if I go into a store, they may give me, they may lie to me about how much something costs. But by virtue of it being on the blockchain, we have a built-in truth to that. We can verify because all of these different computers are all verifying each other all of the time. And once that data has been added, it can't be modified. It's going to be very difficult to cook the books, if you will, to modify, let's say your accounting information. You can't go back in time and modify it. You can't change what has happened. It's virtually impossible for anyone to stop a blockchain from running. You would need to find every single node that's run, every single computer in the world which is running that blockchain, which for most major blockchain networks, that's tens of thousands, if not more, computers running this with tens of thousands of copies. And as long as you miss one of them, the blockchain can keep running. And
Bill, on that,
sorry.
We had a question actually on that topic. Someone asked, what would be a black swan event that would force 100% of nodes being down? So you kind of just touched on that, but I guess it would mean something like a complete power outage, or is there anything else you could add to that?
So yeah, I can think of some really black swan examples. I mean, one would be such a major bug in the code that it modifies the blockchain data itself, that it scrambles it. But even then, anyone running this code or the blockchain or has it backed up, we'd be able to get back to it. Major nuclear war, electromagnetic pulses that destroy electronics or don't allow them to run. I mean, really, as long as think of anything that would allow just one computer to survive, a blockchain network can survive. So again, outside of really black swan scenarios, like a meteor striking the Earth, that's an extinction level event, or such a mess up in code that not only does it destroy all of the data that's that's being stored on nodes, but also any of that data that's been backed up. Again, it is, when I say virtually impossible, I really mean that. Like, outside of really, really extreme events, the network can keep running. Now, there are things that would cause it to run in a less performance scenario where things might take longer, but actually destroying all of that data and having a blockchain cease to exist would be really incredibly difficult. Okay, so I hope that answered your question. So finally, another thing is, due to the fact that all of this data, including your own data, can be put on blockchain, but it's protected by math that others can't view it unless you want them to. It actually can allow us to avoid a lot of major hacks that have been seen. So for instance, like the Equifax hack in the US, a lot of people that had their information gathered about them and stored in one single place. And once that one single place was hacked, then all that data was able to get out. Users on the blockchain, they actually can store their own data there and interact there, but only their data is could even theoretically be at risk. So if I store, my Bitcoin wallet, and like, let's say that I do something really silly and I post my private key, like that's bad. I just lost. So if I do something like I don't secure my own data, I might lose my own money. But there's no way that everybody that's using it could lose all of their credit card information or their Bitcoin information to the world, like what happened with like Target and Home Depot and some of these other hacks that have happened recently. Users really can own their own data. So with these basic pluses in mind, there obviously are some drawbacks to using blockchain technology as well. We'll talk a little bit about those. We have a lot of use cases out there. So instead of having to create accounts on different sites, we could have anonymous logins or use pseudonyms using our digital identity. There's actually some really cool things we can do with digital identities. Like for instance, you may want to prove to somebody that you want to go to a bar, and so you want to prove that you're over 21 or 18 or however old you are. But why do we need to, in order to do that, let people know our full name and what date we were born? We're giving a lot of information out. Using blockchain and using something called zero-knowledge proofs, we actually can do things like prove to someone that we're over 21 without actually revealing our birth date or age. So there's a lot of like these really cool tricks that allow us to have these identities without giving out any more information than we need to. We can have all sorts of anti-counterfeiting systems in place. And we actually see this where different products, they will register themselves on the blockchain and there'll be digital ownership. So anyone can look and prove that you in fact own the IP rights for something, or you own an actual Rolex and not a knockoff copy or something like that, because it can be verified on the blockchain. We can have ownership of your own data. So healthcare is something that we want to tell our new doctor, for instance, like any medical history that we have, but we don't want the world to know about it. We want to let individuals know about it. We want to know who has that information, how it's shared. This is also something that can be done via blockchain. So healthcare is one instance, but there are a lot of places where you might want to share information only with specific people. So this is actually a chart from the World Economic Forum about things that blockchain can be used to help with. So we have voting on the blockchain and other interaction with local governance structures. We can create all sorts of financial products on the blockchain. So Bitcoin obviously is the first instance people have in their mind of money on the blockchain. But there are many different financial products. For example, you can loan money to people, or swap for different tokens, or rent products. You can manage other assets. There are even like like socially responsible things. Like there are different ways that blockchain can be used to keep track of pollution, and it's hard to, again, like alter this. Like you've got an immutable history of what kind of pollution came out from different plants. So whenever you start thinking, what is something that it would be very important for somebody to not lie, and it also might be important for some people to have information and others not to have it, but everyone to verify it, then blockchain is a good use case for that. So I've already mentioned Bitcoin, which first started in 2009. Actually, the Bitcoin white paper came out in 2008, and the description of it and the actual network started in 2009. And just like our internet talk, where there was a history, we didn't just have Google appear out of whole cloth, like Athena from the forehead of Zeus one day. There were earlier attempts at creating digital currencies. So DigiCash, for instance, in the 80s allowed for anonymous cash, but the merchants, the people who actually could accept this money were not anonymous. In 1997, a lot of the basic concepts of Bitcoin were created by a cryptographer named Adam Back with Hashcash. But Bitcoin really brought everything together. And we'll talk a little bit later about in 2015, when Ethereum came out, it allowed applications to be built on top of a blockchain. So Bitcoin is a pretty simple application. It allows you to transfer value from one account to another. Ethereum, a few years later, when it launched, allowed you to develop different applications. It allowed like truly programmable money and programmable applications on the blockchain. And then Dan will be talking about some of the improvements that we are bringing to that with Kusama and Polkadot. So remember I said there were a lot of benefits to using blockchain. Remember, it's immutable. It allows people to trust each other even if they don't know each other. It is extremely hard to try to shut down. But it also has quite a few problems. And I want to go through each of these, but very briefly. Blockchains are inherently very good at interacting with each other, but they're very good at interacting with themselves, like on their same chain, but very poor at interacting with other networks. It's not impossible, but it's very difficult. Just like with their poker game, it's very easy to keep track of what the cards are at your own table, but it's hard to go around to all the other tables and make sure that they're telling the truth as well. It can't scale. These networks can't handle a lot of traffic, and we see them getting clogged up quite often. Poor security, at least for some of these networks. If you want to create your own network, it's actually quite an uphill slog to create a secure network, although Bitcoin and Ethereum themselves have very good security. On that note, why would you want to do that? Well, choosing a single network means there's no customization. It's really one size fits all. And you may have different needs for what you want to produce or what you want to build on. Poor governance system. So it's often very difficult to come to a consensus on the future of the network and what should be done. And finally, upgrades, again, due to the nature of blockchain, are actually rather difficult. And we'll see why. I've got a graphic that I think explains it pretty well. So blockchains are very good at interacting with data stored on them, as long as everybody uses the same blockchain. So just like our example before, we had, if everyone is using the same blockchain, then we can all check on each other. But if some people are using one blockchain and some are using another, then interacting between them is extremely difficult. And we see many attempts at this, but there often are problems, and even in a best case scenario, it's very slow. They're really meant to trust fully any other data inside their network, but are very bad at interacting with other networks without trusting some intermediary. Like, trusting someone who's going to take your message from Tezos and send it to Bitcoin and bring it back. You'd better really trust that messenger. So if we, a system like this, think if we had these different internets all over the world. So every continent had its own, there was like a North America internet and a South America internet. And if somebody wanted to send a message from Pittsburgh to Buenos Aires, then they would have to send a message to somebody they know in, let's say, Panama. That person in Panama would print out the message, go cross the border, go down into Colombia, find a system on the South America internet and type it in. Again, it's possible, but you need to trust the intermediary that they're not going to change the message. And it's very slow and awkward. And scaling issues. So remember I said traditional blockchains, very resilient, but also very slow. It's very hard to stop them, but they're like tortoises, right? They're armored, but they're hard to, they're not very fast. Bitcoin, their theoretical max, about 7 transactions per second, but in reality, it's more like 3 or 4. Ethereum, a little bit more than that, but Visa alone does over 1,700 transactions per second. So a single network, obviously, here is not going to work out. And we see problems with this by having such a small amount of scalability. For a while in 2018, the average price someone was paying to use the Bitcoin network to send any amount of money was $37. And in fact, over the last month from today, fees on Bitcoin are up over 800%. So it's over $5 last I checked. And we've seen similar issues on Ethereum, where when there are popular applications, there's only a limited amount of space for these transactions to go through, and we get a lot of different problems that even can cause people to lose money on these applications. And security issues. So Bitcoin and Ethereum are very secure fundamentally, but if you want to create a new blockchain, it's very difficult to do in a secure way. And in fact, we've seen a lot of different attacks carried out. There's a famous kind of attack called a 51% attack that allows you, again, I'm sort of speaking simply here, to send money to someone and then take that back, right? Say, all right, I'm actually not going to send it to you. I'm going to send it back to myself. And while a 51% attack would be very difficult to do on Bitcoin and Ethereum, if you want to use a different blockchain, you are very, very vulnerable to these attacks. And there have been numerous ones that have happened in reality. The choice then comes down to either using an existing blockchain, such as Bitcoin, Ethereum, but maybe it doesn't have all the features you want. So you want to have one that's specifically made for gaming or specifically made for finance. So you could try to create your own from nothing, which is very difficult. There's a lot of work involved in creating a secure blockchain. So it's very hard to customize. You either have to not customize at all or really start from scratch. Governance issues. It's very difficult, and a lot of these traditional blockchains have no way of determining the future of that blockchain on chain. So you either have a very centralized system with a sort of benevolent dictator watching over the chain and making decisions, or a development team that makes decisions, or just people interacting off-chain and deciding on their own using ad hoc procedures. So most of these blockchains the governance was not really thought out ahead of time. And finally, we have upgrade issues. If you do want to upgrade the software, for technical reasons, really everyone has to upgrade the software ahead of time. So all of these computers, and remember there may be thousands of these, need to make sure they upgrade the software before this major change occurs. Otherwise, you get what's called a fork. So here we see in black at the bottom, the old software, somebody that didn't update. They're going to see different blocks because there are different rules that their software is going to see than somebody with the upgraded software. So if while all of them agree on the previous history, since you can't alter this data that's already occurred on the network, any network that occurs after the upgrade, you may see some people, the people that upgraded, have one version of the pink history here, while other people see a different version, the people that forgot to upgrade or couldn't do it in time. And once you have done that, these chains are now irrevocably sundered. They are now totally different chains. I can't just take the data from the old software and sort of send it over to the new or vice versa. Either we have to just eliminate all of that old software and ignore it, or the upgraded software has to give up and the people use the old software. So these are quite a few challenges that that blockchain gives us. Again, a lot of benefits, but there are also some challenges. So I'm going to let Dan now explain how Polkadot can solve some of these challenges.
Cool. All right. Thanks, Bill. Let me share my screen. And then there were some questions here in the box. Most of these I think we'll get to at the end. And Bill, maybe you can take a look at those while I'm going through these slides. Cool. Can you guys see my screen? Yep. Okay. So back one. Okay, so thanks, Bill, for going through all of that. Now that you guys have a little bit of an understanding of the history of the internet, the history of the blockchain industry, and kind of what challenges exist with current networks, I'm going to start going through Polkadot and how Polkadot's working to address a lot of these challenges. So at the basic level, Polkadot is a foundational building block of the new web, hoping to enable human beings, businesses and enterprises, and governments to use private and secure applications that don't rely on trusting a third party. So Bill mentioned a lot about the Facebook and Google and Apples of the world and how we are relying on their kind of central point of authority. And what Polkadot's doing and what I'll explain here in a bit is how we're building a system that removes the need to rely on trust. Polkadot was founded by some of the earliest builders in the industry, including Gavin Wood, who was a co-founder and former CTO of Ethereum, along with Rob and Peter and a team of people at Web3 and Parity. So the Web3 Foundation and Parity are the two organizations that you'll hear quite a bit as you get into the Polkadot ecosystem. These are the two primary organizations driving forward Polkadot and another project called Kusama. The Web3 Foundation is who Bill and I both work for, and this is an organization based in Switzerland of around 50 of us. Around a third or a fourth of our team are cryptographic researchers. So these are blockchain wizards, essentially, that are building a lot of futuristic specifications for how this technology should evolve. And then they pass those specifications on to teams like Parity, another team called Soramitsu out of Japan, to actually use their software development teams and engineers to implement that in the code. Parity themselves are based in Berlin. As I mentioned, it's a big development shop of around 120 people. And these two organizations work kind of hand in hand on driving Polkadot forward.
Hey, Dan, I'm not seeing your slides.
Oh, you're not? Can other people
it's showing the crowd. It's showing the Crowdcast screen.
Okay, let me.
Sorry, Al.
1 second. Here we go. That's better.
There we go.
Okay. So let's see. Basically what I just walked through was this slide, Gavin, Rob, Peter, the founders of Polkadot, and then Web3 and Parity. So just a very quick recap. And I know we're getting at around 45 minutes, so I'll make this fairly brief. And then if anyone can stay after the 10:30 my time or after the half hour, then we're going to stick around to answer some questions. So using the same framework that Bill went through to explain to you all the existing problems with current blockchain networks, let's use that same framework and walk through the different problems that Polkadot is solving in a very simplified manner, starting with connecting networks together or interoperability. So single blockchain networks include things like Bitcoin and Ethereum that Bill walked through, but also includes custom blockchains built on top of Polkadot. So these will all be singular blockchains in the same manner that Bitcoin is a singular blockchain. But singular blockchains or single blockchains can be built to do one thing really well. So Bitcoin does this digital gold store value use case really, really well. Custom blockchains built on top of Polkadot, for example, for gaming or for finance or insurance or for healthcare, will do one thing really, really well because that's what they're focusing on. Single blockchains from the past have also tried to do a lot of different things just okay. So platforms like Ethereum are trying to do everything from gaming to finance, running the full gamut of things, but they're not focusing on any one area, so it's really tough to be great at one thing. So that same blockchain that I showed on the previous slide, Polkadot, as you can see, is made up of many of these different custom blockchains along this ring here, this relay chain as we call it. Polkadot connects a network of many of these custom-built blockchains into one cohesive kind of living and breathing organism. As I mentioned before, these custom blockchains can be built for specific use cases. So as you see here in the bottom right, these can be built specifically for the Internet of Things, or another blockchain can be built specifically for finance. Another can be built for gaming, and maybe in the gaming example, that blockchain could be built to be super fast, but it wouldn't necessarily need the type of enterprise or bank-like security that a huge bank's blockchain would need, or anything really in the financial realm. And to zoom out even more, the reason why we're really excited about Polkadot's ability to kind of connect all these blockchains together, as Bill walked through, you can see that Polkadot will be building bridges as well to these existing networks like Bitcoin or like Hyperledger for the enterprise use cases, or to our other network called Kusama. Kusama probably deserves its own entire presentation, but just as a quick background, Kusama, as you can kind of see from the diagram, is essentially the exact same code base as Polkadot. But what Kusama is for two things. One, people who are planning to move on to Polkadot will a lot of the times deploy to Kusama first to kind of fine tune their technology before moving it on to Polkadot. And then in the other case, there's people who might want to move a little bit faster or take a little bit more risk, or maybe have a little bit lower of an economic barrier to getting started. That's another use case that we'll see quite a bit on Kusama. So moving on to customization of blockchains. So blockchains on Polkadot, as I've mentioned, are going to be custom built and optimized for specific purposes. So you can think of this like a music producer who uses many tools, including a music equalizer, where they can kind of tweak up, tweak down different aspects of this to change the way the sound works, maybe the treble or the bass or whatever you get into as a advanced DJ or producer. In the same way, Polkadot's blockchain building framework called Substrate is kind of that same idea as the music equalizer. It's basically a drag and drop palette system where people can pick and choose what aspects or what features they want in their blockchain to specifically build it for a specific use case or to be optimized for a specific industry or application or what have you. This is where it starts to get technical. So if you are a developer and interested in kind of how this technology works, I would highly recommend checking out, I will hide this, checking out substrate.io. which is a brand new site that Parity just published, and it has a lot of really great tutorials, explanations, documentation, and so on. Now getting into scale. Polkadot handles transactions at the scale of mass global commerce. Bill walked through the example of Bitcoin starting from the bottom, which has a maximum capacity of 7 transactions per second. Ethereum has a max around 15 to 20 transactions per second. And Visa's actual transactions per second, so what they actually see on a day-to-day basis, is around 1,700 transactions. But Visa can, if they needed to, they can process up to 65,000 transactions per second, according to their website. Polkadot is taking this to a whole new level. Our research team has found that our theoretical transactions per second capacity, so the max, at this point is around 166,000 transactions per second, which is over double what Visa's capacity is. But Gavin Wood even came out recently and said that this could actually, we could see this actually upwards of 1 million transactions per second. So we're really excited about this because we all believe in kind of the vision and what we believe the blockchain industry will turn into. But we really needed as an industry to get to the point where we can handle, Visa, MasterCard level transaction speeds. So governance. Really, there's been 2 primary ways of governance in blockchain. First, no governance, or kind of the way the network was launched is how it will always be. In the case of Bitcoin in 2009, Bitcoin was released, and it really hasn't changed a whole lot since then. The second example is where one person or a small group of the kind of original team has the ability to change and tweak the network's future based on what they believe is the right decision. Where Polkadot is taking this is to a point where the community, the contributors or the actual token holders have the ability to propose things, to vote on decisions, to even vote on a council of people that are kind of their representatives, just like you see in a democratic system in kind of governments around the world right now. So Polkadot's governance system allows dot holders to take part in the network in many ways. I kind of mentioned these already, but proposing public referendum or potential changes to the network, voting on those referenda as participants in the community, and then voting or even running as a council member to be a part of these decision-making bodies that are kind of elected by the community itself. Now, for security, I'm going to walk through an example here. So imagine you're someone named Chad, a work-from-home accountant whose job, of course, is to be an accountant on their computer at home at their desk. But in this case, Chad needed a desk, but he's actually decided to go out and chop his own wood, go to the wood shop and sand and cut his own wood, then acquire nuts and bolts and screws, and then sit there and go through the headache of trying to build his desk, all for the purpose of getting to an end result of just a really plain, decent desk for doing his work as an accountant. But why did Chad go back and decide that he wanted to get into the wood chopping business, the woodworking business, and acquiring his own, nuts and bolts and screws? Now, let's take another example of Thad. Thad is a work-from-home CFO and the need of a desk, but he went about it the smart way. He found one that had free next-day home delivery, and he got it with free triple monitors. So he has no, very low work in actually getting to the point where he can do his job. He's here to be a CFO, be on his computer at home, and that's what his specialty is. And he doesn't want to waste time and effort going and chopping his wood, building his desk, just to get to the point where he can do his job. The reason why I set that up is because that is how Polkadot's security model works. Polkadot makes it super easy for these blockchain teams building their own blockchain to just plug into the existing security system that Polkadot has set up and focus on what they do best, which is coding and building their blockchain. Just like the person who went back and chopped their own wood, created their desk, bought the nuts and bolts, they spent a lot of time doing something that is not their specialty. So we want to do that with Polkadot. We want people to come in, be able to have an existing network of these validators, as we call them, who have this massive amount of security that they can just immediately plug into and not waste their time going out and trying to recruit a whole set of validators to secure their blockchain. So last, I want to walk through an example on the ability to self-upgrade and avoid the situation like Bill walked through with a fork. So take a Shelby GT500 from the 60s or a Tesla. They're both beautiful cars, they're both very fast, they're both highly sought after. But when you buy the Shelby on the left, the car that you get on day one is going to be the same car you get, if not a little bit more deteriorated, after 5 or 10 years. But the reason why people love Teslas, one of the reasons why, is because Teslas can actually upgrade over the air through Wi-Fi or through 4G and actually get upgrades to their car that impacts the different abilities the car has, such as pulling itself out of the garage or parking itself or self-driving features that Elon and his team have rolled out. So we believe Polkadot has a similar model as that Tesla, where it will self-upgrade and be ultimately future-proof, because we will avoid the need to split the network just to introduce a new feature or ability of the network. So as you can see here on the bottom, Polkadot, as it moves from block 101 to block 102 to 104, an upgrade will really just mean that the whole kind of network or system has agreed that this upgrade will take place, and we'll just move right on from 104 to 105 with very little headache and no kind of risk of splitting the chain or dividing the community, as we've seen with other blockchains in the past. So after all this discussion, let's paint a little picture about what the world could look like built on Polkadot here in the very near future. So going back to Bill's example of how TCP/IP and SMTP for email, HTTP, these kind of low-level base technologies, these all enabled the application layer of the Facebooks and YouTubes of the world. In a very similar manner, Polkadot, through our blockchain building toolkit substrate, through other things like cross-chain message passing, which allows blockchains to communicate, bridges to other networks, as I mentioned, this will all enable this application layer that we honestly can't even comprehend, just like Bill said, with people who were creating the internet in the 70s couldn't comprehend that Google Translate could help us translate Spanish to Portuguese, for example. A couple of these have already been kind of underway. So Subsocial is an example of a decentralized social networking platform being built on Polkadot. Akala, a team out of New Zealand, building decentralized finance software. And then Brave Browser is another example of a company that's going into this kind of decentralized Web 3.0 space. But one thing to keep in mind is that so blockchains, when we are successful as a blockchain industry, just like with databases, very successful databases, end users ultimately shouldn't even notice that their app uses a blockchain. So on this slide here, the top icons here on the top are the top 5 most downloaded and used applications in the world. On the bottom here are the top 5 most used databases in the world. But people are not choosing to use Instagram or Facebook because they use a MySQL database or because they use a MongoDB database. In the same way, we will be successful when someone can use an application, maybe it's a decentralized version of Facebook, but we don't necessarily want them to know that they're using a blockchain. We just want the experience to be just as good, if not better, as they're getting in Web 2.0 applications right now. So getting close to wrapping up, what does the world look like in terms of use cases on Polkadot? And this really runs the full spectrum from consumer to enterprise to government. And on the next slide, I'll get into some examples of ones that are already being built. But just to be brief, government blockchains, Bill mentioned identity, land titlings, smart contract law could be very potential use cases on Polkadot. Finance and healthcare or anti-counterfeiting are great examples of enterprise use cases that we will see pop up in the network. And then on the consumer side, this is where you get into the equivalent of a Facebook, Instagram, Snapchat of the world, where it's going to be end users like you and me or our parents or grandparents using things like social networks, messaging platforms that are secure and decentralized, or personal finance, like a decentralized version of Venmo or PayPal, for example. But those things are all great to talk about hypothetically, but let's talk about a little bit of the projects that are already underway. So the Web3 Foundation gives away a lot of grants. We've given away over 100 now, and here's kind of a little graphic of what's underway right now, which really touches on a lot of those consumer, enterprise, and government use cases that I just outlined on the last slide. So these teams that have received grants from the Web3 Foundation are working on everything you can see on the left, from gaming to finance, to even robotics and Internet of Things in the enterprise space. So this is a graphic. There's also, if you Google Web3 grants, there's plenty of information you can read if you are a developer interested in receiving or applying for a grant, or if you're interested in just learning more about all these 100 projects here on the right and what they're building right now. So that's about it. One other thing that I wanted to mention is that Polkadot's getting very, very close, within days of beginning our launch process. If any of you have questions about the launch, I'm also willing to get into that a little bit as far as how the launch will look, but we're going to be having a phased launch starting very soon that we'll see rollouts getting to the point where we have kind of full decentralization and launch of the Polkadot network. So we're getting really excited for that. And then for this, so we have a bunch of links here that I know you can't click on my screen, so we'll be sending these out in an email after this as a follow-up for giving you ways to get involved. One thing that myself and Chris Hutchinson work on quite a bit is the ambassador program. We've got around 50-50 split of developers and non-technical people who are joining a group of around 200 people around the world in 45 countries that are really contributing quite a bit to the ecosystem. So that's a really great way to get involved, as well as following us and staying updated on everything. So I will let Bill come on too, and we can start going through questions.
Hey, if you could use the ask a question button, that's going to be easier for us to. I see people asking in the chat box, but if you go to, there should be a ask a question at the bottom here. Dan, could you click on it? No, yeah, well, whatever. Thank you.
Yeah.
All right. Thanks, Hutch. Oh, it's telling me to ask questions. So, yeah, I was just going to go from the top down, but since I'm not the host, I can't click on them. So, Dan, if you could just click on them for me.
First one. Sure.
All right, thanks. All right. So this is asking about actually building what we call a runtime. So I don't. I'm happy to talk to you about this offline. At least what I know. I'm not a substrate everyday developer myself, but I know different palettes are operating at different levels of the runtime. So I'm not sure why specifically balances in session one is considered runtime and one is not. But I'd be happy to send you links about that. I just don't want to get too much into detail right now because this was meant to be the non-technical thing. So for the next one, also from same person. So Substrate is the way for people to develop their own blockchains. Remember that we said there's sort of right now only like two divergent ways of doing this. You can start from scratch or you can use an already made one. Substrate is I like to think of it as like the Ruby on Rails or like Wix, where like anyone can just, as Dan said, just sort of bring different palettes and make their own kind of a blockchain. Regarding a runtime upgrade, we can actually look at Kusama for some of these practical runtime upgrades. For instance, the number of validators. So that is, think of them almost as like miners on Bitcoin, the ones who produce the blocks. There are trade-offs between having more and fewer of them. The more we have, the more decentralized the network, but there are some technical issues that would make producing blocks a little bit slower in that case. And so one upgrade that we have done, a runtime upgrade, was actually changing the number of validators on the network. So that's done by a vote. In fact, I think there's a vote right now on Kusama for increasing the number of validators. And once people vote on that, that they're actually voting on a function call. They're voting on new code to change the network, and that is a runtime upgrade. There have been other runtime upgrades that we've done. I want to say we're at around 40 or something. I can't remember off the top of my head on Kusama. To other things like adding registrars, so like adding people that are authorized to registration and provide digital identities to people. So if you go, actually, there's a site, Polkassembly. You can see some of the discussions on previous referenda that were runtime upgrades. All right, so I'm going to go to the next one here. Polkadot is like an agency or corporations. So yeah, but remember, this is an analogy. He's not saying it's actually an agency or a corporation. But yeah, so what you would do if you want to make a change to the network is issue a proposal. I actually have a whole talk on how the governance system works. But you can propose anything. You can propose to change the entire code of the runtime. You could propose to add a new blockchain into the network, or you could propose, although I don't think anyone would vote for you, to give yourself 1 million new tokens. To do this, there's a standardized process where you submit this proposal for a vote in a formal manner, and people can second it, and then it becomes a referendum, and people can vote on it. And if a majority of stake agrees with your proposal, it will take place. So there are all kinds of things that you can do with that, all the way down, like I said, to modifying the runtime itself, replacing all of the code. But it's done in a democratic way.
And I'll add one thing to that too. Gavin's been using a word called agency also to refer to the fact that the users have the influence or power. So kind of a different definition of the word agency, but it's kind of referring to my slide about how the network actually has the ability to have a voice or an influence on the governance versus what we've seen in the past, where you really don't have a voice in the way the network moves forward.
Yeah. Okay, so back in the 90s when the web was released, you had to buy a dedicated server or run a second phone line. We do offer there is light client support, so you don't have to run an entire Polkadot node to use Polkadot, or an entire Kusama node to use Kusama. You can, obviously, and we support that. Anyone can do it. However, we also really, I would say this is really from the engineering side. There are a variety of ways to interact with the network besides just running your own node. So you actually can create transactions offline. If you want to do it entirely offline and then take it to a node, just like our hypothetical distributor from Panama going to Colombia, you can do that. You can. What I assume most people are going to use are these third-party providers. So their applications will let you interact with it. Just like, if you think about it, you aren't directly interacting with Facebook's database, right? You have this nice web interface, and then it sends data to a database behind the scenes. And what we see is that a lot of these networks, like Akala Network's current testnet, there's no indication that Polkadot is running behind it. I go to a website, I connect my wallet to it, they use Polkadot in the background. So I think we're doing the same thing, that you don't have to host a node on your portable laptop. There are third-party providers that allow interfacing to Polkadot. I understand Kusama chain is pre-Polkadot. Is it possible Kusama will become official Polkadot chain? That's not really in the plan whatsoever. But Kusama was released, right? It is now in the hands of the community. We, as the Web3 Foundation, have no control over it. So while what we envision is that Kusama is going to be the testing ground, and that's how we plan to use it. But remember, we don't have any control over it. So there are a lot of Kusama maximalists out there that really like Kusama and they want to interact with it. It really is, as someone said, it's the Wild West. We're doing all sorts of interesting experiments on Kusama right now. Like the society, right? What's it called? The fraternity. So if you get a Kusama tattoo, you can get Kusama tokens. So you can just do a quick search for Kusama tattoo. I'm sure you can find that and put on-chain proof that you got this Kusama tattoo. We envision Polkadot as sort of the more staid, solid, older brother or older cousin of Polkadot, and it's been designed that way. So Kusama decisions are made very quickly. The governance goes very, very fast. Things change very quickly. So in terms of like the official Polkadot chain, we made Polkadot to be slower, more staid, more conservative, and that's what how we continue and are going to continue to support it. But again, both of these are going to be decentralized. So an official Polkadot chain, it's really going to depend upon the users. Okay, so next question. Would it be possible for a quick comparison to Cosmos? So this would be difficult to do without getting too deep into the technical side of things. We actually have a page on our wiki. If you just go to wiki.polkadot.network, there is in search for Cosmos, we have a whole page. But I'll say from a very high level, Cosmos does do some similar things. They really work on having blockchains interact with each other. The main difference from a sort of a 50,000 foot overview is that in Cosmos, these chains are really independent. They don't share security. The onus is on the individual networks really to have their own system of security, their own ways of interacting, and Cosmos really is focused just on the interoperability. Polkadot, on the other hand, we're really trying to be more of a one-stop shop where we can provide this cross-chain compatibility. We can provide this shared security so that all of these different networks that are produced can all share security together instead of worrying about it individually. And also Substrate, where we have a framework for developing your own chains and adding on to Polkadot. That's not really something that Cosmos has. They do have their own software development kits, but I would say the big, again, high-level overview is that the chains are more independent in Cosmos, which has benefits and drawbacks. Okay, so next question. Notwithstanding the differences in technical approach, what differentiates Polkadot from Solid and Rupt? So I'm not that familiar with Solid and Rupt. I know that's Tim Berners-Lee's project. So I think, based on what I know, though, I may have difficulty explaining it in non-technical terms. But really, that seems to be more of the format of the data that can be shared between applications, not really like the truth or falseness of it, like that you handle with a blockchain. So it's really meant at the application level, how do we share this data in sort of a universal format? Whereas that is less of a concern with Polkadot. Now it's part, we will have this interaction, but it's really going to be at a sort of a more fundamental level where we have, as opposed to sharing from app to app, it's really these apps would all share to the blockchain. But I think, again, based on what I know, which is not a lot, there are very similar goals in the long run. The differences really are like the technical approach to how we want to, we all want to see more shared data, more decentralization. It's, what is the approach? And there are, again, like, technical, there are drawbacks and benefits to any kind of technical approach you make to it. But I'm not familiar enough to really dive deeply into Rupt. I'm sorry, Solid, I'm sorry. Two-part question here. An estimate on transaction fees. Well, transaction fees occurs in dots. So I can tell you average transaction fees on Kusama right now are 0.001 Kusama for most ordinary transactions. The concept of transaction is a little bit more complex than that on Kusama or Polkadot. So giving a specific number is going to be difficult. Transaction fees will occur in DOTs just like they occur on Kusamas. We don't know exactly what they're going to be yet, but I would estimate in terms of absolute numbers, less than in Kusamas, but it's hard to say. But again, right now it's 0.001 Kusama for an average transaction fee currently. Compared to the complexity of using sorry, there was a second part to that. Where was that? Okay, I got it. Will the I see it. Compared to the complexity of using Ethereum, how will the UX get friendlier for average Joe and Jane? Honestly, this is a problem in all of the blockchain space, and it's something that we are working on. And one of the ways that the UX gets friendlier is if we have these specific interactions. So I think one of the problems with using something like MetaMask, again, MetaMask, great tool. Don't get me wrong. I use it all the time. But it's meant to be everything for anyone, right? My crypto can call any, my crypto can call any contract, or MetaMask can call any contract, and you as a user are focused on being able to do anything. And even now, like our current UI, it really allows you to do anything if you want to. And I think one of the things that we really want to focus on, just like the different blockchains or parachains as we call them, that connect to the network will have different topics and different focuses. We will have different UIs for different things you'd want to do with the blockchain. So, like theoretically, think of it like in the old time, right? You had the old time, like when I was 20. You had a command line, and you could do all sorts of things from the command line. It's super powerful, but it's also very difficult and very hard to understand. Whereas now, like I look at Snapchat or whatever, and I press a button and it puts cat ears on me or whatever the latest filter is. And, I just press a button because I can't do a lot with that. I can put cat ears on myself, but not anything else. And I think that's one of the keys to UI, is making sure that we do one thing and do it well. And by having these different chains and different UIs for the chains, then I think our UI, we're gonna see that improve. Okay, ability to connect legacy networks. Will there be an ability for blockchains that have been devised as consortium blockchains utilizing Parity, Ethereum VM, and POA to be connected to Polkadot? Yes. So there are already there are things in our grants program for connecting any of these like POA networks, and because we already have experience with this, this is something that I believe is on our roadmap. With the bridges and with the system that we have, most of these legacy blockchains can be bridged to Polkadot. Now, the one problem is that is sort of you have to do one and then another. There's not a standard to just, all right, I bridge to a blockchain, right? It's a bridge. I build a bridge for this. I build a bridge for this. I build a bridge for this. But we are seeing, and you can look this up in the grants, people building bridges not just to the POA networks, but also we're talking about Kusama, Bitcoin, Ethereum per se, the mainnet, and others. And really, any traditional blockchain, as long as we write up people write up the code for it, we can bridge to. All right, last one. Are validators shared across parachains, or does each chain need to build its own network of validators miners? So the validators, this is sort of a terminological thing, are shared between all of the different chains. So the validators are the ones who produce blocks on the main, what we call relay chain, the chain that sort of connects all of these other chains that others build. However, these individual chains will also need to develop something called collators. And collators send the data really to the validators. So they are the ones that are going to communicate from your network to the validator. Somebody is going to have to let the relay chain know what's happening on your particular chain. So there's actually a variety of ways that this can occur. They can be built into the nodes of your chain. You could do it in a sort of proof of authority way where certain nodes are allowed to be collators. You can develop like an economic system to incentivize people to send this data to the relay chain. There are actually quite a few different ways that you can do this. So the validators, remember, they're on the relay chain. They're not on the parachain. Everyone shares them, all of the different parachains. But each individual parachain needs collators to send the data to figure out what's happening and to receive data. And so they are going to have to, each chain is going to have a network of those. All right, I think that was the last one. So Dan has put our contact information. Please feel free to contact me on any of those, and I'm happy to answer your questions.
Cool. Well, does anyone else have any questions? Or I know we've gone like 80 minutes now, so appreciate everyone who's still here, and hopefully you learned a lot from this presentation today.
All right, thank you, everyone.
Cool. Okay, have a good day or good night.